Hey guys, Miss Subin here. So I'm going to be showing you how to deal with terminating decimals and turning them into a fraction. Our objectives today stays the same. Today we are going to review how to convert values between fractions and decimals without changing the value. And today it's okay for you to use a calculator. Just make sure you're using a calculator that's not on the device you're watching me on, because I don't want you to get all lost and confused. Before we get started, let's define what a terminating decimal is. A terminating decimal is a decimal number that contains a finite number of digits. That just means it doesn't go on forever. So, our examples that I have here are 1.2, done. 0.25, ended. 67.35742, the end. The only times that it's not going to be a finite number of digits or a terminating decimal is when you see something like this, 1.2, and then if they put a dot, dot, dot on it, that means that it keeps going and they just didn't feel like writing it. A lot of the time you'll see this when there's a lot of digits already. One point two five six eight seven dot dot dot. That means that it keeps going on forever. This is not terminating. Another example of not terminating would be a repeating decimal. So when we see that like 0.3 repeating, that little hat on top, that means that it's not terminating because it goes on forever. This is the same as 0.33333 dot dot dot, going on forever and ever and ever. We're focusing only on decimals that have a definite end, like these ones here. All right, so decimal to fraction conversion. The numerator is the value after the decimal. Our denominator is always a power of 10. Now, powers of 10, that's when you take a 1 and multiply by 10 over and over again. So 1's a power of 10, 10 is a power of 10, 100's a power of 10, 1,000's a power of 10, so on and so forth forever, because we're taking 1 and multiplying by 10. So right now I have 10 million times 10, that's 100 million. Times 10 is a billion. So I have a couple of examples written down for you. So when I say power of 10, that's what we're looking at, is 1 with a certain number of zeros after it. Now, the decision you have to make is to decide how many zeros should I use. The number of zeros matches the number of digits that are after the decimal. When you're done, you'll have a fraction. Whenever we deal with fractions, you always need to remember to simplify. So let's give this a try. Example 1, rewrite 0.5 as a fraction. Well, our numerator is always the value after the decimal. Well, here, our value after the decimal is 5. So 5 is the numerator. Here's the tricky part. Our denominator is a power of 10, where the number of zeros matches the number of digits that are after the decimal. Well, looking back at our original problem, I only have one digit after the decimal, 5, the number 5. So 10 is going to be the denominator because there's only one number after the decimal, and 10 only has 1 0. So let's go ahead and put together our answer. We said 5 is the numerator, and our denominator is 10 because there's 1 0 and 1 digit after the decimal. This has the right value. 5/10 is the correct answer. However, we can write this better. We always want to remember to simplify. So we need to think 5 and 10, what can we simplify by? We're going to use what we learned in class to check for those more common divisibility rules. I'm going to be checking for 2, 2, excuse me, 2, 3, 5, and 10. We're not divisible by 2 because 5 is not divisible by 2. We're not divisible by 3 because 5 is not divisible by 3. We are divisible by 5, so I'm going to divide by 5. So I am going to do 5 divided by 5, which is 1, and 10 divided by 5, which is 2. And simplifying is where the calculator may come in handy, because you can put in the calculator your division, and if there's no remainder, then it's divisible and you can use it. But our final answer here is 0.5 is equal to 1/2. I'm going to go ahead and move on to the next example. We're rewriting 0.75 as a fraction. 0.75, the numerator is always the value after the decimal. Our value after the decimal, 75. 75 is the numerator. Here's the hard part again. The denominator is always a power of 10. So 1, 10, 100, 1000. We pick which one of these to use by picking the number of zeros that matches the number of digits that are after the decimal. So here I have 2 digits after my decimal, so I want to use 2 zeros. 100 is the denominator since there are 2 digits after the decimal. So for my answer, I'm going to put 75 as the numerator because that's what's after the decimal. And for my denominator, I'm going to use 100. Again, we pick 100 because there are 2 digits after the decimal, 7 and 5. So we want 2 zeros in our denominator. However, we are not quite done yet. We want to simplify to give the best answer we can. So again, I'm going to check those most common divisibility that are easy to check. Are they divisible by 2? No, because 75 is an odd number. Are they divisible by 3? Yeah, but I don't really feel like doing 75 divided by, oh no, 75 is, but 100 is not. So we cannot divide by 3. Can we divide by 5? Yes, we can divide by 5. Because it ends in a 5 and a 0. 75 divided by 5 is 15. Then 100 divided by 5 is 20. So now we have to check again. Can I divide by 2? No, because 15 is an odd number. Can I divide by 3? I can divide 15 by 3, but I can't divide 20 by 3, so no. Oh, I can divide by 5 again. "15 divided by 5 is 3, and 20 divided by 5 is 4. If you need to see the screen for longer, you can pause here, but I'm going to go ahead and move on to the next set of problems. All right, so now let's try this on our own. So what we're going to do is we are going to convert the following into fractions, and we're going to write it in its simplest form. So same rules will always apply. We want to use what's after the decimal for our fraction and for our numerator. So after our decimal here, we just have 7. Then we want to use our powers of 10. So 1, 10, 100, 1000, and so on as our denominators. we pick which one of these based on how many numbers were after the decimal. In 0.7, we have one number after the decimal, so I'm going to use 1, 0. So my denominator ends up being 10. Then we just have to check if we can simplify by 2, 3, 5, and 10. This doesn't cover all the different ways that you can simplify, but this covers most cases, and these are the ones I want you to recognize. 7 cannot be divided by 2 because it's an odd number. Let's see, can I divide by 3? No, 7's not divisible by 3. Can I divide by 5? No, 7's not divisible by 5. And can I divide by 10? No, 7's not divisible by 10. So at this point, you're done with this problem. If I'm ever going too fast, you're welcome to pause the video and then catch up with me whenever you're ready, or continue with me whenever you're ready. But I'm going to keep moving. Next one I have is 0.24. So again, we're looking at the numbers after the decimal, 2 and 4. So we have 24 as our numerator. Our denominator, we want to use a power of 10 that has the same number of zeros as we have digits after the decimal. So here I have 2 digits after the decimal, so I'm going to use 1, 2 zeros. Now let's see if we can simplify. I can simplify by 2 because both are even numbers, so I'm going to go ahead and do that. 24 divided by 2 is 12. 100 divided by 2 is 50. And if you don't know that division, you can always plug it into your calculator. You can put in 24 divided by 2 and get 12, and put in 100 divided by 2 and get 50. I know I'm not done though, because 12 and 50 are also both even numbers. So I'm going to divide by 2, divide by 2. 12 divided by 2 is 6, and 50 divided by 2 is 25. Now we have that odd number of 25, so I can't divide by 2 anymore. Let's check if I can divide by 3. 25 is not divisible by 3. If I can divide by 5, 6 is not divisible by 5, and I cannot divide either number by 10. So this is our final answer for this problem. All right, so now let's go into our next problem here. This one's a little tricky, even though it looks not too bad. 0.006. So again, the numbers after the decimal are our numerator. Well, 006, we know that's the same as just 6. And then our denominator is a power of 10 that matches the number of zeros with the number of digits after the decimal. This is the part that's tricky. We have to count all the numbers after the decimal. 1, 2, 3. So I'm going to use 1, 2, 3 zeros. Some of you may not have counted those zeros here, but zeros are a digit. They are a number, so we do count those. We only count the ones that are after the decimal, and that's why we didn't count that other one. There's 1, 2, 3 numbers after decimal, so I use 1, 2, 3 zeros. This has the correct value, it's the correct answer, but we're asked to simplify. 6 divided by 1,000, both of those are divisible by 2. 6 divided by 2, that gives me 3. 1,000 divided by 2, you can put it in your calculator if you need it, is 500. At this point, I cannot simplify anymore. That's the end of this problem. Last one we have here, I recommend that you pause the video and I want you to try it on your own. When you're done, you can play my video and see if you get the same thing. So pause me right now. All right, so I think we're ready to move on. For this problem, we put the number after the decimal for our numerator. Our denominator, we want to match the number of zeros with how many numbers are after the decimal. After the decimal, I have one number, so I'm going to use 1 0. They're both even numbers, so I'm going to divide by 2. 8 divided by 2 is 4, and 10 divided by 2 is 5. At this point, I hope you have enough of a grasp that you can try some of these on your own. I'm not expecting you to be an expert yet, but this is something that you should know when you're an adult. It's something you should be able to do. So for you to be a functional human being, you need to be able to do this. This is not just filler work. This is something you need to know. Now, you may have noticed in all these problems that we had something in common. They all had the same whole number of 0. Now, this happens a lot in math, but it's not what happens all the time. There can be other numbers here as a whole number, so we have to think of one more step to do. It doesn't make the problem any more difficult, but it's something we need to consider and it's something we need to do. So I consider this a special case, when there's a whole number in front. So the example we're going to do is 13.4. We're going to convert the part after the decimal, just like we just learned. So we're going to look at just 0.4. Sorry, my thing's being weird. Just 0.4. Let me try writing that again. 0.4. So for 0.4, we're still going to use the numbers after the decimal, 4, as our numerator. Then the number of zeros in our denominator matches the number of digits after the decimal. We have one number after the decimal, so we're going to use 1 0, which makes 10. So when I write this out, I get 4 over 10. This has the right value, but we want to simplify if we can. 4 can be divided by 2, and so can 10, because they're both even numbers. 4 divided by 2 is 2. 10 divided by 2 is 5. At this point, we can't simplify anymore. Based on what we did on the last page, you might think that we're done, but we're not done yet. We're not done because we haven't done anything about this 13 here yet. 2/5 is equal to 0.4. We're being asked what is 13.4. So the last thing we're going to do is we're going to add the whole number back to the final value. So 13 plus the 2/5 that we got in the last part of the problem. Well, good news for you, when you add a whole number with a fraction, you just put them together and that's your final answer. So our final answer here is just going to be 13 2/5. Now there is another kind of special case. It's called a repeating decimal. These ones aren't terminating because they're repeating. We're going to talk about this another day. It is possible, but it's brand new. I am going to tell you that when we learn this repeating decimal conversion, it would help you if you are really good at this terminating decimals, the ones that we're learning today. The two are very similar. So the better you are at today's stuff, the better you'll be at next class's stuff. So let's give this a try. We're going to convert the following into a fraction and make sure to simplify our final answer. So 4.5, again, we still look after the decimal first. So the numbers after the decimal, 5, over a power of 10, and we want one number after the decimal, so we're going to use 1 0. 5 and 10 can both be divided by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. Since there's a 1 in my fraction, I can't simplify anymore. It's tempting to think our answer is 1/2, but this is equal to 0.5. I want to know what's 4.5. So I need to add back in my 4 to my 1/2 and get 4 and 1/2. At this point, what I'd like for you to do is, if I'm going too fast, please pause and make sure you have everything I have written down, and then you can move on whenever you're ready. Next problem, we have 6.25. 6.25, I'm going to start with the numbers after the decimal in my numerator. Then my denominator is going to match with 1, 2 digits after the decimal, so 1, 2 zeros. Then right away I see I can divide by 5 because I have a 5 and a 0 as a last digit. So let's divide by 5. Again, I'm moving kind of quickly. You can pause me whenever you need to. 25 divided by 5 gives me 5. 100 divided by 5 gives me 20. Right away I notice I can divide by 5 again because we end with a 5 and a 0. 5 divided by 5 gives me 1. 20 divided by 5 gives me 4. Since there's a 1 in my fraction, I know I can't simplify anymore. But I shouldn't be circling that answer because we're not done yet. That's just the value after the decimal. We still have to factor in the number before the decimal, 6. Since 6 is a whole number, we're going to add that to our fraction, and our final answer will be 6 1/4. I recommend pausing the video here and trying the last two on your own. Then I can go through and I can check the answers with you. All right, I'm going to go through these very quickly. If you need me to talk to you in another time, just let me know. This is something that you need to know, so please don't just shrug it off and move on. So, this one, we start after the decimal. 72 is after the decimal, so that's my numerator. My denominator is still a power of 10, and this time I want 1, 2 numbers after the 1, 2 zeros. They're both even, so I'm going to divide by 2. 72 divided by 2 gives me 36. 100 divided by 2 gives me 50. They're still even numbers, so I can divide by 2 again. 36 divided by 2, and again, if you don't know it, use a calculator. And 50 divided by 2 is 25. At this point, we can't simplify anymore, but it's not my final answer because we have to add back in our whole number, 26 18/25. That is one that I wouldn't be able to do in my head, and I'd have to do this way. All right, last one here, and this one's a trick one because it has that 0 in it. My numerator is the numbers after the decimal, but 0.6 is the same thing as just 6. Then I have my denominator is going to match the number of digits after the decimal. 1, 2 digits, so 1, 2 zeros. They're both even numbers, so I can simplify. 6 divided by 2 gives me 3. 100 divided by 2 gives me 50. I cannot simplify anymore, but this is not my final answer because we had the whole number in front. So my final answer is 17 and the 3/50. Please go back and rewatch if you need to, but at this point, I'm going to leave you to try to do some on your own.